When I first came across the mysterious Tabby's star, I was hooked right away. This star has caught people's attention not just because of its weird light changes, but also because of what those changes could mean. Found by the Kepler Space Telescope, Tabby's star shows strange dimming patterns that don't really make sense with what we know. Tabby's star is acting super weird because its brightness dips in a totally random way, not like the usual stars that dim predictably when planets pass by. This has got everyone talking and wondering what's up with it. The mystery has caught the attention of both scientists and space fans, with some even calling it the alien megastructure star, suggesting that maybe aliens are building something huge around it. The whole concept, while super intriguing, has kicked off a wider chat about hunting for alien life and imagining what it could be. As I dug into it more, I couldn't help but wonder about the impact of such a discovery on our view of our place in the cosmos. The odd dimming of Tabby's star has led to an exciting theory that maybe some advanced aliens have constructed a giant array of solar panels or other structures to gather energy. It's just speculation for now, but it's definitely got people thinking and chatting about the chances of life beyond our planet. As I got more into this idea, I started thinking about how far we've come with our tech. Imagine if we could actually build massive structures in space. Would we finally chat with aliens, or just keep to ourselves forever? The idea that we might not be the only ones in the universe is super intriguing, and Tabby's star gives us a glimmer of hope in our search for answers. But while these possibilities are thrilling, they also highlight the need to keep our explorations rooted in solid science. The Kepler Space Telescope has played a huge role in broadening our knowledge of the universe, and its findings have changed how we view exoplanets and star activity. Since its launch in 2009, Kepler's main job was to spot Earth-like planets around other stars by keeping an eye on their brightness. During this mission, it discovered Tabby's star, which showed some really unusual light patterns. Kepler's data has been a goldmine for learning about different planetary systems and the chances of finding habitable worlds. Going through all the info from Kepler, I was amazed by how many exoplanets we've found, more than 2,300. Every new discovery helps us learn more about the universe and makes us wonder about life beyond Earth. Tabby's star has some funky light patterns that have really stood out, getting scientists all curious and ready to explore more. The telescope's real legacy isn't just the numbers it cranked out, but how it's fired up a new crowd of astronomers and space lovers like me to wonder about the universe. The scientific community's response to the discovery of Tabby's star has been marked by a combination of excitement and skepticism. Following the release of the initial findings, researchers swiftly proposed various hypotheses to elucidate the star's anomalous behavior. While many were mesmerized by the notion of extraterrestrial megastructures, others called for caution, stressing the importance of acquiring further data prior to jumping to any conclusions. This divide highlights a common struggle in science, balancing wild ideas with hard facts. I loved following the chats among scientists about Tabby's star, and it was cool to see so many theories come to light. Some researchers were more cautious, leaning towards natural explanations for the star's dimming. One of the leading theories proposed to explain Tabby's star's unusual dimming is that a large planet is orbiting it. This theory posits that a massive exoplanet could be passing in front of the star, causing temporary dips in brightness as it blocks some of the light. While this explanation seems plausible at first glance, it raises further questions about the size and nature of such a planet. Would it be gas giant like Jupiter or something entirely different? As I pondered this theory, I couldn't help but appreciate how it reflects our evolving understanding of planetary systems. The discovery of exoplanets has revealed a stunning variety of worlds, each with its own unique characteristics. If a large planet were indeed responsible for Tabby's star's dimming, it would add yet another intriguing layer to our knowledge of celestial mechanics and planetary formation. However, as compelling as this theory is, it remains just one piece of a much larger puzzle. Another explanation for the mysterious behavior of Tabby's star involves dust formation in its vicinity. This theory suggests that clouds of interstellar dust could be obscuring the star's light intermittently, leading to the observed dimming patterns. Dust can accumulate in various ways, through stellar winds or remnants from previous celestial events, and its presence could account for some of the irregularities seen in Tabby's light curve. It may seem mundane at first glance, but dust is essential for star formation and can significantly impact our observations of distant objects. If dust clouds are indeed responsible for Tabby's star's fluctuations, it shows just how interconnected and complex our universe truly is. While this theory offers a more conventional explanation, it does not entirely dismiss the allure of more extraordinary possibilities. The idea that cometary activity could be influencing Tabby's star's brightness is yet another hypothesis. This theory suggests that a swarm of comets might be passing through the star's system, creating temporary obstructions as they orbit or collide with one another. Such events could lead to sporadic dimming as these icy bodies reflect or absorb light from the star. Comets are often seen as harbingers of change. Their unpredictable paths can lead to spectacular displays or catastrophic impacts on planets. If comets are indeed responsible for Tabby's star's fluctuations, it would highlight not only the star's unique environment, but also indicates how little we understand about celestial interactions. The space dust hypothesis posits that fine particles surrounding Tabby's star could be responsible for its unusual light pattern. These particles might be remnants from previous stellar activity, or even debris from colliding celestial bodies within its system. It is pretty amazing, isn't it, that even minuscule particles can have significant effects on astronomical observations. Dust plays an essential role in shaping our understanding of cosmic phenomena. It can obscure light from distant stars, or contribute to the formation of new celestial bodies. If space dust is indeed affecting Tabby's star's brightness, it's just proof that even insignificant elements can have profound implications in our quest to understand the universe. The evaporating moon theory presents yet another fascinating angle on Tabby's star's dimming behavior. This hypothesis suggests that a moon orbiting a planet near Tabby's star could be disintegrating due to intense radiation or gravitational forces from its host star. As this moon breaks apart, it could create debris that intermittently blocks light from reaching us. The idea that moons can evaporate or disintegrate adds an additional layer of complexity to our understanding of planetary systems and their evolution over time. If this theory holds any merit, it would not only explain some of Tabby's star's peculiarities, but also provide insight into the life cycles of moons and planets throughout the cosmos. The interstellar dust cloud theory posits that an external cloud of dust could be passing through Tabby's star's line of sight, causing its light to dim sporadically. This hypothesis emphasizes how interconnected our universe is. Events occurring far beyond our immediate observation can still impact what we see from Earth. Each explanation offers a unique perspective on what might be happening with this captivating star, reminding me that science is an ever-evolving journey filled with questions waiting to be answered. Whether it's through natural phenomena or something more extraordinary, my fascination with Tabby's star continues to grow as we strive to uncover its secrets and explore what lies beyond our own world. Catching one of these in a sample of 150,000 stars is like hitting the jackpot in space. With around 100 billion stars just in the Milky Way, it means there are probably millions of these events happening right now, way more than astronomers thought. Naturally, the probabilities don't always work out this way. It is possible that we were fortunate and directed the Kepler telescope towards a star undergoing an event with a 1,000,000,000 likelihood. Alternatively, the entire hypothesis could be entirely incorrect. Another possibility is that the dust isn't orbiting Tabby's star at all. Instead, it might be floating around in the massive space between us and the star. This idea is intriguing because an irregular cloud with changing, but generally increasing, density moving through could explain everything. Those deep dips, no clear pattern, and even why it's been dimming over time. It all kind of fits, well, almost. Turns out Tabby's star's odd dimming might not be so odd after all. The events are just far enough apart that we didn't catch them at first glance. With more time spent observing, some scientists reckon there's a cycle happening roughly every 4 years. So, if all this odd behavior is just because of some random interstellar dust cloud, not even related to Tabby's star, there shouldn't be any pattern, and you'd expect other stars around there to be affected too, but it seems like only Tabby got the memo for this space shindig. big. So, what's the takeaway from all of this? As of now, researchers believe that dust is responsible for the unusual behavior of Tabby's star, though its exact source and location are unclear. Despite these unknowns, there remains a slight possibility that aliens could play a role. Could super smart aliens have made a swarm with tiny nanobots around Tabby's star? It's possible, but honestly, there's probably a simple explanation for all this that we just haven't discovered yet. Thanks for watching.